Okay, welcome everybody to the Introduction to Object-Oriented Programming webinar. I'm Jeff Perlman. I'm the founder and CEO of Xojo, and with me is Paul Lefevre. He's one of our esteemed engineers here. So if you have any questions along the way, there's a Q&A panel in Zoom. You can fill your questions in there. Some of those questions Paul will be answering privately. Others will answer at the end in a little Q&A session. Now I'm going to start with a few remarks and then we'll get into Xojo itself. So first of all, let's talk about some of the questions we'll be answering. This is not all the questions, but some of the questions we'll be answering in this webinar. What is object-oriented programming? Do I need to know it to use Xojo? How do I use it to write code? How is it going to make my code better? And things like, I've heard terms like subclassing and inheritance, maybe you heard encapsulation and things like that. And what do those really mean and how do I use them? So those are the kind of things we'll be covering. Now, oh, and more, of course. So if you're like me, you probably got started with a procedural programming language. For me, it was AppleSoft Basic, long time ago, then a little bit of Pascal, and then I taught myself C. So those were all procedural languages. And you know, when you learn a procedural language, you learn to write subroutines and declare variables and things like that. And later I heard about object-oriented programming. And the idea that I could think of code as objects just sounded really interesting to me. So my first exposure to that was actually with the Newton. I don't know how many of you remember Apple's Newton. It was their first personal digital assistant. Well, Newton came with, if you were a developer, it came with something called the Newton Toolkit. And the Newton Toolkit was a visual development environment. It had a language, it had an object-oriented language. And in fact, I got a picture of it here. That will bring back memories. And I really thought that I was going to learn object-oriented programming from this. But it turned out that they wrote this with the assumption you already understood object-oriented programming. So I couldn't really use it very much at all. So that was kind of a drag. But then years later, I came across what became Xojo. And of course, Xojo's language is object-oriented from the very beginning. But what I noticed about Xojo was that unlike other development environments like the Newton Toolkit, it didn't kind of force you to learn object-oriented programming. You could kind of get started and pick it up as you go. In fact, I feel like for myself, and Paul, you might want to comment on this, but for myself, I didn't sit down and learn object-oriented programming. I just kind of absorbed it as I learned more and more about Xojo. So that's one of the things that makes Xojo different. So going back to that question, do I need to know object-oriented programming to use Xojo? Well, yes and no. I mean, you can get quite a ways with Xojo without feeling like you really understand object-oriented programming, but to get the most out of it, you certainly want to learn as much as you can. So what is object-oriented programming? Well, object-oriented programming is simply a way of organizing code and data that work together into groups. Those groups we call classes. Now, you can do this in a procedural language, but it's a lot more work. Object-oriented programming sort of enforces this organization, making it easier for you. Now, maybe it's because I'm a visually oriented kind of person, but the idea of creating objects from code kind of made sense to me right away. Now, like I said, when it comes to needing to know it, you'll be able to do better in Xojo if you understand object-oriented concepts. Things will make more sense to you. If you've been using Xojo for a while and felt like, gosh, I know it's object-oriented, but I don't feel like I totally understand that, then I think a lot of what you learn in this webinar will help with that. Now, one way that I express object-oriented programming to people who have never done it before is when you think of a spreadsheet, right? I've got a piece of a spreadsheet here called people, and it's got columns, name and birth date. Now that's data, right? I enter those, but then it's got an age column, and you can see there's a formula for that. So the age column is code in a sense, whereas the other columns are data. And that's a good example of an object. Each of these people might be considered an object, and the way we organize that with object-oriented programming is into a class. So you might have a class that's a person, for example, and I've got such a class here. So in Xojo, I could have a person class, and I could have properties for name and birth date, just as I have in the spreadsheet. And then I have a method attached to that class, age, which is the formula for computing the person's age. So spreadsheets, in a way, are kind of, individual tables in a spreadsheet are kind of sort of similar to a class. The only difference is you kind of have to have data in a spreadsheet to even create it at all, to put in the formulas. Whereas when you create a class in Xojo, you can create it without having any data yet at all. By the way, as a side note, if you've had some really complex spreadsheets that you found weren't operating properly because the formulas were just getting too complex, you probably found out that spreadsheets don't have a debugger. And one of the things I did a long time ago when I ran into that was I just created a class like this that mapped to the columns of the spreadsheet. And then I imported the data from the spreadsheet into the properties, creating an object for each row. Well, then I could just debug it using Xojo's debugger. So that made dealing with those formulas a lot easier. I was kind of surprised afterwards that I didn't think of that right from the beginning. So but you can think of a table in a spreadsheet as sort of the equivalent to a class in Xojo. Again, you've got some columns that are data and some columns that are code. And of course, we call those methods. So let's say, for the purposes of this webinar and discussion, that you need to write an app to track some products. So I'm going to use that as the example. So I'm going to switch over here to Xojo. 1 second, I need to switch my screen. Okay. Switch to the other screen. Here we go. Okay. So I've got a new desktop project. I could do this in any kind of project, iOS, web, it doesn't really matter, because object-oriented programming is separate from all of that. So I'm going to create a class because I want to track products. So I've got my new class here. I'm going to call it products. And I need it to have the kind of stuff that you typically expect for a product. So I'm going to create some properties. Let's start with a part number. And let's see, a description. Make that a string. And a price. Make that a double. Okay. So we've got some properties for our product. Now, that's great if your products are all pretty simple, right? You can create an instance of this. For example, let's go back over here to the window, and I can add a button. And in the pressed event, I'm just going to create an instance. Now, if you've never really worked with objects you created yourself, when you declare variables, regular variables with static data types like integer and double and all that, you just say var my variable as my type. But if in object-oriented programming, if you're going to create an instance of it, in other words, an instance of a class to hold some data, then you need to use the new keyword. So I'm going to say var p as new product. I called it products. Okay. So this is going to create an instance. Now I can say p dot part number equals, let's say 100, and p dot description equals, what should we call this? Let's call it, here, let's say it's a book. Okay, how I turned 1 million in real estate into $35 in cash. There we go. Okay, and it needs a price. and we'll make the price $50. Okay, so I've created a new instance, varp as new products. Yeah, okay, so I've got a new instance. I've filled in some properties, and that's great. But let's say that you sell lots of different kinds of products. This is a very simple one. Let's say you also sell hardware, for example. Well, I could go to my products table, or products class rather, and I could add all the extra properties I need to keep track of things that are physical hardware. Like you might need to ship it, so maybe you need to store the dimensions of the box, its weight, all that kind of stuff to compute shipping. But then let's say you also have another kind of product that's a service. Maybe you have many services, and those are going to have their own properties. Maybe you need to store the term of the service, whether it auto renews, that sort of thing. So you could end up with a class that's got all of these different properties in it that you only use for certain things. And that can get a little messy and complicated. Well, one of the things you can do with classes is you can separate them into what are called subclasses. So a subclass has everything that its parent class has and more. So I'm going to create another class, and I'm going to call this one hardware. And in this case, it's super, which means its parent class is going to be products. Actually, I'm going to, yeah, there we go. Actually, I'm going to call that product. Oops. Let me fix this. I should have been just product. There we go. It makes more sense that way. Okay. All right. So this hardware class is a product. It's got everything that the product has, description, part number, and price, and then I can add new things to it. So for example, I'm going to add to this depth, and I'm going to give it some dimensions. So depth and height and width or length. And let's add weight. Okay, all the information that I would need to know in order to know it's, what it's going to take to ship it. So now I've got this new type of class called hardware that is a product. It's got description, part number, and price in it too, but it's also got these additional properties. And I can do the same thing with a service. So I'm going to create a new class, and I'm going to call this one service. And once again, I'm going to set its super, its parent class, to product. So it too is a product. Now, this can go as deep as you want. I could make, if I had unique kinds of hardware that had their own properties that weren't shared by all hardware, then I could have a subclass of hardware, and I could just keep going and going. So for service, I'm going to add, let's see, I'm going to add auto renews, and I'll make that a Boolean because that's just true or false. And I'm going to add term in months. Okay, so now I've got 3 classes. Great. Okay, so now see, I lost my cursor here. There it is. Okay, so now that we got our classes, we want to try doing something with them. And let's go back and start doing that. So I'm going to make an array, and I'm going to add a instance of each of these classes to the array. So I'm going to say var products as product. So now I've got an array of products. There's nothing in it yet. It's just an array of products. And I've created a new product here like I did before, and I can add that to the array. Okay, so now let's do the same thing. Let's make a piece of hardware. So var h as new hardware. And it has, like I said, all of the properties of a product. So I can put h dot part number equals 200 and h dot description. You can see that these all autocomplete from the parent class equals quantum computer. and h dot price equals, oh, those are expensive. Let's make that, what's that, $50 million or something. Okay. And then I can add that to the array as well. And I can add it because a hardware product or hardware class object is a product class object, right? So products dot add h. And last but not least, let's make a service. And we'll say s dot term in months is 12 and s dot auto renews equals true. And then we can add that to the class, or to the array rather. Okay, so at this point, we've created an instance of each of these classes that they're all ultimately products, so we can put them all into an array together, and then we can do something with this array. Now, I'm gonna put some interface on here so we can actually see this. So let's go get a list box. And let's see here. Let's make this, let's make this 4 columns. Okay, and for initial values, I'm going to make this, let's see, part number and description and price and details. And we'll get to details in a minute. Okay. And 1 second, I need to. Okay. There we go. All right, so now we've got this ready to go. And now we're going to add these products that we created to this list box. All right. So it's an array, so I'm going to loop through the array. So I'm going to do for I as integer equals 0 to products dot last index. So that's my loop through all of the items in the array. And then I'm going to make var a product as product equals my products. Sorry, products. Okay, so now we've got a product that we're going to add, and we're going to add it. So I'm putting this in a variable. You'll see in a minute. I'm putting this in a variable just to make this a little easier when I'm adding it to the list box. So list box 1 add row, and we'll do a product dot part number dot toString, and then let's add the description. So a product dot description, and finally a product dot price dot toString. Okay, so we add it to the string, or we add it to the array rather. So this will be enough so far. Let's see what happens. Oh, and I'm going to need to, yeah, I need to share my whole screen. Give me a second. Okay. So there's our window. Press the button. And what happened there at the end? Did I not fill it in? Oh, yeah. Huh. I didn't actually fill in the part number for the service. So part number equals 300 and s dot description equals tech support, let's say. Okay. Try it again. Okay, so there's our data, right? Wow, that's a big number for that quantum computer. Okay, so that's great. But all we're doing so far is we're just putting in the data that's common to all of these things, whether it's hardware or a service. It's all still just product information. How would we access the information that's unique to the subclasses themselves. Like the quantum computer is hardware, the tech support's a service. How do we get that information? Well, that's what I'm going to do next. So I'm going to make it so that some of the information appears in this details column over here, so you can see how to access information about a specific subclass. So the first thing we need to do is we need to know whether this particular product we're looking at is a hardware product or is a service product. Well, the way you do that is using something called ISA. So I'm going to put if products I, so we're accessing the element of the array, is a hardware, then end if. Okay, so if that's true, if this is actually one of these class objects, if this particular array element is one of these objects, a hardware object, well, then we know we've got a piece of hardware. Now, at that point, we can now add it to the detail cell. So I'm going to put listbox1 dot cell text at listbox1 dot last added row index, and I think it's the third column, third index. Okay, and what we want to do is let's get, oh, you know what I didn't do? I didn't add any data here. Let's put the weight in here. Weight equals 50. Okay, so we want to get the weight in there. So I'm going to put the word weight, and then we want to add the weight to the details column. How do we do that? Well, what you'd think you could do is just say something like this. Products, this is what your intuition would tell you. And then you'd think, well, now I can just access the weight, right? But oh, look at that, it's not auto-completing. Why is that? Well, because products is just a product. It's not a hardware, it's not a service, it's just a product, and only hardware has a weight. So what you have to do is you have to turn this product into a hardware product, into a hardware class object. And there's a really easy way to do that. It's called casting. So you just put the name of the class in front of it and put it in parentheses. So you're passing the object here, the array element, to this and converting it into a hardware class object. So now you've got that. And you'll notice that now if I type a period and I use autocomplete, look at that. There's all the stuff I can access in a hardware product, including weight. Oops, I meant to click on weight. Let me hide this. There we go. Okay, there's weight. And of course, weight's a number, so let's convert it to a string. Okay, and so we should be all set at that point. So you test to see if the item is a certain subclass. If it is, then you can turn it into that subclass by just passing it to the name of the class in parentheses. And again, after that, you can then use dot and access the properties and such. So let's give this a try. Oops, what did I do wrong? Let's see here. I missed something. Syntax error. End if next. Okay, it's right in here somewhere. 1 second. Oh, there's the end of that. It's this right here. Okay. Okay. Let's try this again. And there it is. There's the weight. So we've accessed something from the subclass and put it right into that field, or that column rather. Okay, so now you know how you could do that. And of course, you could do it with the service class as well. Now, another element of object-oriented programming that you'll run into is where, let's say you need to track whether or not different products are taxable. Okay, now your instinct might be, well, I'm going to go to my products class and I'm going to handle it there. But what if the implementation of how you compute tax varies? Like, what if it, hardware has one kind of tax, depending on where you live. Sometimes things that you sell are taxable, whereas things that are like services are not. or sometimes it's the other way around. So you may need the computation, the method, the logic to be separate for each of these types of objects. So there's actually a really good way to do this, and it's called an interface. So an interface is a way of setting up a set of methods that go together. It could be just one, it could be many, and then telling various classes to implement those methods. So the interface itself is just the method names and the parameters. It's not the actual implementation. The best way to understand this is to see it. So I'm going to add an interface. Let's see, class interface. And I'm going to call my class interface taxable. And I'm going to add a method to it. Now, I'm going to call this, let's see, I'm going to call this is taxable. And I'm going to keep this simple because it doesn't really matter what the parameters are. I'm just going to make this a Boolean. So is it taxable or not? Yes or no? Now you'd think, well, this is the code editor, right? I'm going to start implementing it, but that's not what you do with a class interface. The implementation is in the class itself. So now that I've just defined this method as part of this interface, and again, you can have as many methods as you want in an interface. That's just sort of an organizational thing. I can now go to hardware, to that class, and you'll notice you've probably seen this in the inspector interfaces. I'll click choose, and you'll see that most of these interfaces are provided by Xojo. You can ignore most of those, and if you ever need them, then you'll go looking for them. But here's the one that I created, taxable. So I'll click that, click OK, and now you'll notice that hardware has a method called is taxable, and it even puts this comment in for you, part of the taxable interface. Now, to keep this really, obviously I could have a really, sophisticated implementation. The implementation isn't important, so I'm just going to return true. Okay. And then I can go down to service, and I can choose that same interface. And now it has an is taxable method. And let's have it return false for this. Okay. So they both now have this method. And the real benefit here comes from being able to generically refer to these methods. For example, let's see, let's say we go to our button again, and let's go to our loop. And what we want to do is we want to call the taxable method if this thing is part of the taxable interface. If it implements that interface, that means it has this method, and we can generically call it. And I just realized that I need to add a column so we can see that. So let me go over here, and I'm going to make this 5 columns now. And I'm going to call this one taxable. Okay. And let's see, I need to do one other thing here. I want that to be a checkbox, just be more fun than having the word true or false in there. So I'm going to go to the opening event here and put me.column type at for equals desktop list box dot cell types dot checkbox. There we go. Okay, so now it'll be a checkbox. All right, so in our loop, we need to know, is this product that we're looking at taxable? Is it part of the taxable interface? And that's actually really straightforward. It's kind of like seeing if it's a subclass. You say if products I, and you use ISA again, ISA, and this time it's taxable because that's the name of the interface. Okay, so if that's true, then products basically has the taxable interface, which means we know that it has the is taxable method. So now we're just going to call that and set the checkbox. So we'll say if products, if taxable products sub I. So we've now cast it as part of the taxable interface. In other words, we know it supports that interface. So we're just turning it into that. Then look at that. I don't even have to press tab. There is the is taxable method showing up, right? Or so it's going to return true or false. So I'm just going to say if is taxable then, and we'll put end if. Okay. So at this point, we know that we have a product that's taxable and or potentially taxable anyway, because it's part of the taxable interface. And we've cast it as a taxable interface object using the keyword here, taxable, the name of the interface. We've cast it, and then we can do dot is taxable to call the method. So this is calling the individual is taxable method on whether it's hardware or service. We don't know, we don't care. It's just going to call it. And if that's true, then what do we want to do? Well, we want to add a checkbox. So, or rather check the checkbox. So I'm going to put list box 1 cell checkbox state at list box 1 dot last added row index for equals, here, let me hide this so you can see the code. Desktop checkbox dot visual states dot checked. Okay, that should do it. So let's run and see what happens. Okay, so there's our taxable column. Press the button, and there it is. It checked the checkbox for quantum computer because that's hardware. So it called the is taxable function, and that returned true. So it checked the box. And for the other things, the first one is a product. And let me expand this a little bit. Oh, I didn't make them resizable. Okay, anyway. First one's just a regular product. It's not part of the taxable interface, so it didn't check it. And the last one's a service, and the is taxable function of the service class returned false. So there you go. So using classes, you can organize your data and your methods into groups that make sense, and you can then add methods to individual classes. Of course, we did it with a interface, but you don't have to use an interface. Interface works when you have multiple classes that have a method that they're all going to share, where it's the same way, you call it the same way, maybe it's the same name, same set of parameters, but it's going to have a different implementation for each class. Now, of course, you could add other things that have nothing to do with interface. For example, I can go back to hardware and add a method, and let's say I need to compute shipping, right? So I can call this shipping cost and have it return a double, let's say. And then I could have some implementation in here to do all the computation on the depth, the height, et cetera, to figure out what the shipping is going to be. I'd probably also have maybe a shipping method that gets passed in to determine the shipping cost. But anyway, you can have methods that are just for specific classes. And that makes a very handy way for you to organize your code. Now, another thing about using classes that you want to eventually kind of get to know is the idea of scope. So I'm going to go back and let's go to part number. And you look over here in the inspector, and there's a scope property, right? And you've probably seen this before, and it's got these 3 values: public, protected, and private. And what do those mean? Well, public means that this property is accessible from anywhere. If you've got an object of type product, you can get to its public, to get to the part number property in this case, right? It's accessible from anywhere. If you choose private, I'm going to skip protected for a second. If you choose private, that means, and you'll see it turns sort of salmon colored here. that means that property rather is only accessible inside of the class itself. And you think, well, what good is that? How's that going to help me? Well, when you're writing methods for a class, you will ultimately find over time that you end up needing to store data that only the class itself needs. And when that happens, that's a good time to start making things private. And the reason is that as your application gets bigger and maybe more complicated, and you start, using your objects from different places, you don't want to accidentally access the wrong thing. Something that was really meant to only be used inside your class, you don't want to accidentally access it from the outside. So if you just go ahead and take the extra step of setting the scope to private, you don't have to worry about that. I'm going to show you a kind of complicated example of that in a second. Now let's go to protected, the middle option. Protected means that this is accessible to the class and any subclasses. So it's not really private and it's not really public. It's this class and any subclasses. So in this case, part number would be available to product, to hardware, and to service because they're subclasses of product. But outside of that, it would essentially be private. So that's what those are. Another thing to remember about scope is that the Xojo IDE remembers the last thing you set it to. So if you're making a bunch of properties and you know they're going to be private, and you pick one and you say private, you make another one, it's just going to default to private. So just be cognizant of that, because if you're not, you might end up making something private that you meant to be public, and it's a shortcut, but you just need to be aware that it does do that. So that's how scope works. Now, to give you an idea of how all of this can get, pretty big, pretty fast, let me show you one of my own projects. Let's see. Okay, I'm going to go here. Okay, so this is a project I'm working on for all of you to use, dbKit. It's to make it easier to build front ends to databases. And dbKit itself is a module, and I pretty much put it in a module just to make it easier to keep it all nice and organized. It has classes, and the class that does most of the heavy lifting is called dbKit Connector. It's the class that connects to your database and then loads all the data after you do a query and get a row, it loads all the data into your controls. So it's got a lot of stuff in it. It's got a lot of properties. You can see that. You notice the ones that are, salmon colored, those are private, right? Those are things that only the code in the class itself is using. I should never be accessing any of this from outside, so I make it private. Same with methods. You'll see that most of the methods in here, probably about, I don't know, half of them or 2/3 of them are also marked private as well. Again, it's just a way to make sure you're not calling the wrong thing from the wrong place. But there's another benefit of using private or using scope, and that is autocomplete. When I go to call methods of dbKit Connector, you can see there's a lot of them, right? Well, let's go to a window and go to db Connector's open event. And just so you can see the autocomplete, here, I'm going to put call because that will get functions as well, because I really just want you to see the autocomplete. I'm going to put me, okay? And you can see that now I'm only seeing the items that are actually public. All the rest of the stuff that's private doesn't show up. So it really helps you to not accidentally choose the wrong thing, and it keeps the number of things. Now, this is a big list, but it keeps the number of things that you end up looking at when you autocomplete to a minimum. Now, again, this is a really big class, so keep that in mind. Another place where I've used subclassing, actually. Sorry, let me back up. I've got a interface here. So this is dbKit control, and it's got a bind method. The purpose of this interface is I have a bunch of subclasses. We talked about subclassing. I've got a bunch of subclasses for controls, and I wanted to be able to easily identify which classes are dbKit controls. So all my controls have this interface. So let's go look at those. So if I go to modules, you'll see I have a desktop module and a web module, because those are the two project types I support at this point. And if I go inside that module, go to classes, and I've got a bunch of classes here where these are actually subclasses of the controls that they're named for. So for example, DB checkbox is a subclass of the desktop checkbox. You can see that here. And it supports the dbKit control interface. So I can loop through the controls and use that as a keyword to determine if a particular control on a layout is a DB checkbox control or not. And again, this is a subclass. So why did I subclass a control? Well, I wanted to add my own features to it. For example, to know what part of the database it comes from, I've got the table name of the database, the column name of the database. It's got a method to bind that column and table and column to a particular instance of the checkbox. So I've added my own stuff. I've even added my own event handlers. So I've got an implementation of the opening event and the value changed event. And then I create event definitions. I've got those here so that the user still gets those events on the layout. In fact, if I go to, let me go back to this window, I've got a checkbox here, and you'll see if I double click, value changed and opening are there, so the user can implement them themselves. So that's why in that class, you've got, I'm implementing the event handlers, but then I'm creating event definitions, and you can see I call the event there. So my code runs, it's very simple, enabled equals false, to enable it or disable it by default. And then it calls the opening event just in case the user has implemented that. So this is a pretty big project. And when you're starting out with object-oriented programming, you're probably going to keep things pretty simple. But you can see that you can really organize things quite a bit. Like I said, I've got a subclass in here for each control that allows me to put the code that works with a particular control just inside that control. Same with the data that I need. What was it? In the web, yeah, the web, let me get to that class, set of classes. So the image viewer, for example, on the web, so it has an image property, and I needed to scale the picture, but I also needed to keep the original picture that was being stored from the database. So I added my own current image property that stores that picture. So I use the image property of the image viewer itself to show a scaled version, but I still have the original unscaled image in this property. And that's so the user can drop the picture onto the image viewer, which is right here. I can drop it on there, and then I can show it scaled in this small box in the image viewer, but I can also keep the original version to store in the database. So that's just another example of where I used a subclass and added a property to it. Okay, I could go on and on and on forever on object-oriented programming. The great thing about object-oriented programming is that you can learn a little bit and just keep incrementally learning more and more. I for a long time, I didn't use exceptions, something we didn't talk about today, for doing error handling. And then I learned what they were. And this was years and years ago. And then I started using them in my code. So the nice thing about object-oriented programming is you don't have to learn all of it to use any of it. You really can learn it incrementally. My guess is that many of you are thinking, I've kind of been doing that all along. Like if you were accessing, maybe you have a button on a layout and you're accessing another control. Well, and accessing a property of it. Well, if you did that, you're doing object-oriented programming because you're accessing properties of another object. All of the controls you have on a layout, those are all objects. So yeah, so you really can learn as you go. All right, so I'm going to look at some questions here. Actually, let me switch back to the yeah, let's hang on a second. I'll switch back to the slide. Okay. And we have some questions. Okay, so Ed's asking, why didn't the compiler flag a type error when you assign the hardware and software types to a product array? Can you use ISA in a case statement? Okay, so there's two questions here. He's wondering, why is it that we didn't get an error when we were assigning a hardware or software item to the array that's a products array. It's not a hardware array. It's not a service rather array. It's a product array. Well, it's because the product array, or rather the hardware and service classes, they are products. Remember, I set their super property to product. So a product array can hold the types of any of its subclasses. Now, having said that, you won't have, like I said when we were going through it, you won't have access to the properties that are unique to the subclasses unless you cast them. And that's where we used ISA. His second question was, can you use ISA in a case statement? Yes, you absolutely can. I've done that. And then I'm not going to butcher your name, so I will just ask the question, or I'll just state the question. Does using classes and subclasses have an effect on memory usage and speed? Well, there are always trade-offs. Classes use memory, but if you're going to store all of that data and you're going to have the methods anyway, the amount of overhead for the object itself isn't really that much. And with today's computers, everything's so fast anyway. But in all of the time that I've been using Xojo, and that's going back to 1998, the overhead of a class has never been part of the equation at all, really. If you are creating, millions of objects and performance, you've got a super performance intensive situation, you might run into a situation where you say, okay, maybe I need to have fewer subclasses, or I need to store this all in just arrays because it has to be ultra fast. But that's going to be the absolute rare exception. Definitely not the typical scenario at all. I think that's it. Thought we'd have more questions at the end, but it doesn't. Oh, wait, hang on. There's one more. No, that's an answered question. Okay, here's one more. Christian's asking, when destroying a class, how do I tell the parent to refresh information? I'm not sure what you mean about destroying a class. If you deleted the parent class in the IDE itself, like if I deleted products, then you would need to go to your subclasses, and I haven't tried that actually, but I think you would need to remove the super property. I would expect to get a compiler error because it would say the class is missing, the parent class is missing, if that's what you mean. Okay, here's another question. The method call you had earlier didn't have a set of parentheses as they're optional. How would you pass in parameters? The method call, for like taxable, for example. You do it the same way. I didn't pass any parameters to the isTaxable method, but if I had defined parameters in the interface for that, not in the implementation, not in the class itself, not in hardware, not in service, but in the taxable interface class or interface itself, if I had added parameters there, then I would need to be passing values in, and I would have said in the code is taxable open paren, gave it the parameters close paren, just like you do with a normal method. Okay, I'm getting a few more questions here. That's great. We've got time for them, so I'm going to answer them. Tim is asking, can you talk briefly about computed properties? Right, computed properties are really interesting. We didn't have them at first, but we added them after a number of years. But what is a computed property? A computed property is essentially how do I put this? It's a hidden property that's exposed as two methods, a getter method and a setter method. So one method you pass information to set the value, and another method, you get the information, it's a function, you get the information back. So instead of having a property that's like, let's say it's a double, and instead of having I don't know, price, right? Maybe you want to have a formula, some code that computes the price based on other values. So you create a computed property in your class, and then you end up with these two methods, and you typically create a private property behind the scenes that's going to store the value. I mean, you could be storing it elsewhere, but that's most typical, is to have a private property. And then to your code, it looks like a regular property. When you call it, you just assign a value, you get a value. But behind the scenes, what's going on is when you assign a value, the setter property, or the setter method rather, gets called. And when you get a property, the getter method gets called. And so it acts like a property, except for it gives you the opportunity to call code when you're setting or getting the value. So that's what a computed property is. It's one of those things, here's what I'd say about a computed property. A computed property is the perfect answer right when you need it. So like, you're not going to use them a lot probably, but you find yourself needing to do what a computed property does. And hopefully you'll remember this webinar and you'll say, hey, he said something about computed properties, and you'll go and you'll look it up and find out, yes, the perfect solution. Okay, so someone else is asking, could you discuss method overloading? Yeah, so method overloading isn't exactly an object-oriented thing, but the idea is sometimes you need to call, you want to call the same method, but you want to pass in different parameters. And I'm going to show you actually a good example of that. I'm going to share my screen again. And I'm going to switch back here to my project. Okay, and let's go into DB connector, and we'll go into the methods, and let's go to bind entry control. So this is binding a control in the UI to a column in the database. And you'll notice that some of my methods have these little disclosure triangles next to them. Well, that's because they're overloaded. So they have more than one signature, more than one set of parameters. So I'm going to go to bind entry control, and look at that, there are two. So I'm going to click on one. The first one passes in, well, let's go over here. The first parameter is a control, is a desktop UI control, and then a column, right? But I have another implementation that's for the web. So if I click on this, the basic difference is control as web UI control instead of desktop. So these two methods, the implementation is almost identical. It's just the parameter that's different. Now, they could have different implementations, of course, because in a sense, it's really two different methods. They just have the same exact name. So when you create a method and you give it the same name as a method you already have and different parameters, then the IDE will automatically display them this way, and that's method overloading. Now, in my case, and I want to show you something that's kind of related to this, in my case, I have a desktop version of the method and a web version of the method. Well, another thing you want to do here is, I'm going to click on desktop. If I go over to the advanced tab of the inspector, you can see the included section. I'm only including this in the desktop. So when I compile for desktop, this method will get compiled in. If I go over to web and go to advanced, it's going to only be included in the web version. That's how I can talk to I'm in a desktop project here, but I can actually include a parameter that's a web class control, and I'm not getting, or web class, and I'm not getting compiler errors. How's that possible? Well, it's possible because I've told it that this method, this signature of this method, is only being compiled for the web, and this one is only being compiled for the desktop. So when I compile for the desktop, which is what this project type is, it's going to skip this signature entirely. So that's a great thing about both overloading methods and the include attributes here. So you can actually create classes that work across multiple platforms, which is really great, multiple project types. All right, we got time for a couple more questions. Richard's asking, when bringing data from databases into an array of classes, how can you tell how many to limit it to? So he's asking, hey, if you're going to load a bunch of data into an array, how big can those arrays get? Well, obviously that's going to be limited to memory. And then you're going to start hitting things like performance. And really, you kind of have to judge it yourself. If it's a single user application and the database is local and it's a good computer, well, maybe you don't have 1 million rows. So maybe it's fine to just load it all into arrays. If it's a server that's being accessed over the internet and there's millions of rows and you really don't know how many are going to come back, well, then maybe you need to get a little more sophisticated. And then you start, loading maybe, a small number of rows and then give the user an interface. It's more than we can go to in this session, but you can do it dynamically so that you're loading data as the user requests it rather than loading it all up front. Okay, and let's see, one more. Okay, it looks like this is more of a feature request. Will is saying, I'd love to be able to create folders within methods, properties, etc., sections of objects. Yeah, for organization, that's not a bad idea. I've wanted that too, especially in a situation like this where you've got a lot of methods or properties or whatever. It could be nice to have another level of organization, not so much for calling them, but just to be able to create a folder and organize all of the methods that do a certain task into a certain area. I totally agree with that. And one last question, then we got to end things. The question is, can a class be a subclass of multiple classes? And the answer is no. That's called polymorphism. Some languages support that, where there can be multiple parents, like people. But we don't support that. That has its own set of problems. It has features, but problems too. So the way we give you the functionality of that is with interfaces. So you can, rather than having multiple parent classes, you can create interfaces, have your subclasses subscribe to those interfaces and implement them. And then when you're calling code, you can have a class, any class you want. You can have it subscribe to as many interfaces as you want. And so that kind of gives you the equivalency of what you're doing when you've got multiple parent classes in other languages. Okay, so let me get back to my primary slide here. All right, so that is that's it. I really appreciate everybody coming. If you have more questions down the road, please contact us either through tech support on the forum, etc. And I appreciate coming, and we'll have more of these webinars in the future. If you guys have ideas for webinars you'd like to see, make sure you write to us and let us know. We always love your feedback. And thanks for watching. Till next time, bye-bye.